Hi everybody. So in this video, we're going to look at how we can model with normal distribution. We'll work through 4 parts of a question. In the first one, we'll work through parts A and B. And then in the next part, we'll work through questions C and D. So we're told that a restaurant monitors the time taken for its kitchen staff to prepare orders. And the manager believes that the preparation time can be modeled by a normal distribution with a mean of 16 and a standard deviation of sigma minutes. We're given that 10% of the orders take longer than 22 minutes. We need to show to 3 significant figures the value of sigma, the standard deviation, is 4.68. So the first thing we need to do is we need to define our model. We'll say that the random variable x is distributed normally with a mean of 16 and an unknown standard deviation. Now, if we sketch the normal distribution curve, we can illustrate this mean as being at this point, and then we're told that we're given 10% of the orders take longer than 22 minutes. So we can show this on the right-hand side of the curve, and this region will have an area of a probability 10% or 0.1, and this is at 22 minutes. Now we can use the formula where the standard normal distribution is equal to x minus mu over sigma. Now we have mu, this is the average of 16. We have the x value of 22, and we want to work out sigma. So we need to work out the z value, and we can do this using the standard normal distribution. This is where the mean is 0, and the standard deviation is 1. So if we use the inverse normal, and we'll go to our calculator, then we'll choose distribution. We want to scroll down to inverse normal. Now, because the calculator takes the area from the left, we want this area underneath the curve. And we know under the curve is 100%. So if we go back to our calculator, we know the area will be 0.9. And because it's the standard normal, the mean will be 0, and sigma will be 1. And we'll execute that. So we have the z value of 1.281 or 1.282. So I'll write this on the curve as z equals 1.28 to 2 dp. So now we've got the z value here, we can substitute this into the equation. So we've got 1.28 will equal the x value, which is 22, minus mu, which we know is 16, over the standard deviation. So now we can tidy up this right-hand side. We've got 22 minus 16, which will give us 6, and we'll move the sigma over to the left-hand side. So 1.28 sigma will equal 6, and then we'll divide both sides by the 1.28. And this will give us the standard deviation of 4.68, which is what we wanted to show here. Then for question B, calculate the percentage of orders that will take less than 13 minutes. So now we can put this standard deviation back into our model. So x is distributed normally with a mean of 16 and a variance of 4.68 squared. And then we want to calculate the percentage of the orders that will take less than 13 minutes. So if we've shown this on the curve, we'll have 13 here, and we want to work out the area of this region. So we want the probability of x being less than 13, which we can work out on our calculators using normal CD. So we'll go back to our calculators, go back, we'll choose normal CD. Now the lower you can see is 3 standard deviations below the mean, or anything less than that. So I'm going to put in 0. The upper you can see is 13. We know the average is 16, and we've just worked out the standard deviation as 4.68. So we've got the probability will be approximately 0.26. Okay? So that's parts A and B. Let's try part C. So now we're told that a senior chef claims that his average preparation time is less than 16 minutes. He records the data on his own preparation times. So 20% of his chef's orders take more than 17 minutes, and 10% of his orders take less than 8 minutes to prepare. We need to work out an estimate for the mean and the standard deviation. So do you want to give this question a go yourself using the standard normal distribution? You can pause the video and come back when you're ready. Okay, so welcome back if you had a go. So the first thing I'm going to do is I'm going to sketch each of these on a normal distribution curve. So you can see that we have the mean, mu, and 20% take more than 17 minutes. So we're looking at this region here. And then we've got 10% take less than the 8 minutes from this information. Now to work out mu and the standard deviation, we need to use the standard normal distribution. So if I sketch these out separately, we know the area we're looking at is 20% or 0.2. So we need to work out this value of z. I'll call this z1. And then for the second one, we know the region underneath part of the curve is 0.1. And we need to work out this z. I'll call this z2. And we can work out each of these values using the inverse normal. So if we go back to our calculators, we'll choose inverse normal. For our first graph, we're looking at the area to the left, so that'll be 0.8. It's the standard normal, so the average is 0, and sigma is 1. If we execute that, we get Z1 as 0.842. So I'll write that on the graph here. And then for the second one, we'll clear this. Now we're looking at the area of 0.1. We've got the same average and standard deviation. So for Z2, we've got negative 1.28. Now we can use the equation where Z will equal x minus mu over sigma. We know for the first one, Z is 0.842. And this has a corresponding x value of 17 minus the average mu over sigma. So therefore, 0.842 sigma will equal 17 minus mu. We'll say 0.842 sigma plus mu will equal 17. And for our second curve, we know z is negative 1.28. The x value is 8 minus mu over sigma. So therefore, negative 1.28 plus mu will equal 8. And now we can solve these equations simultaneously on our calculator. So I'll go back to the calculator. I'll choose home, equation, simultaneous with two unknowns. The first equation, we've got 0.842. We've got 1 and 17. And then for the second one, this should say negative 1.28 sigma. So negative 1.28, 1 and 8. Convert that to a decimal. So sigma will be 4.24 and mu will be 13.42 or 13.43. Okay, so that's question C. For part D, state, given a reason whether or not the calculations in part C support the chef's claim. So we found out that mu, the average, is 13.4. If we compare this to the average initially of 16, you can see that this is less than the previous average. Then this supports his claim that his preparation is less than the 16 minutes. So we'll say as mu of 13.44 is less than the 16, the senior chef's claim is supported. Okay? Well, thank you very much for watching. I hope you found that useful. If you want more lessons on the normal distribution, you can download them from my website, mrmathematics.com. I'll leave a link in the description below.